I just wanted to say a few words about inverse functions with our trigonometry. And I have no idea what makes sense to you and what doesn't, right? I mean, I don't know you, so I don't know. But I know when I teach this class in person, inverse functions can be a little tricky about what that means and what's going on. So normally, the sign of 0 is 0. Okay, well then this is still 0. But what does that mean? And the cosine of 0 is 1. Okay, so what is the inverse cosine of 0? It's pi over 2. Where is that coming from? What does this even mean? Okay, um, let's talk sine first. So inverse sine of some x. Inverse sine is defined in the first region and the fourth region of the quadrants. Okay. So inverse functions. Maybe you learned this in your pre-calculus class or your algebra 2 or whatever. When we define an inverse function, we have to make sure that the function is one to one. The way we do that is we restrict the domain. So by restricting the domain, we have to pick certain areas where this thing works. And what we picked for inverse sine before me or you were born, but they picked region 1 and region 4 for the valid regions, okay? So it only works here and here, okay? And then for cosine, we're going to restrict it going this way. So it's region 1, region 2. Okay. All right. So when we say the inverse cosine of 0, it's pi over 2 because that's the x coordinate that equals 0. Okay. So even though there is a spot over here in which the cosine is also 0, right? 3 pi over 2, it's also true. It's also true over here. But we made the decision that it's only valid in regions 1 and 2, not over here. It's not in 3 or 4, it's 1 or 2. So that's why this is pi over 2. Okay? And that's confusing because it has to do with inverse functions, which have to be one to one, which is something that's all set up in a previous class. It's not set up in this one. It's just a consequence of those actions. Okay, so that's the idea. Now, the other consequence that happens, so for cosine, right, you're in region 1, region 2. So all answers, like if you use a calculator, do I have a calculator? Yes. So even if I use a calculator like this, and I say, okay, what's the inverse cosine of 1/2? And it'll give me some angle which happens to have 1/2. It's only going to give me the answers here. It will not give me any answers down here. And there's a few spots where you want that. Okay, so inverse cosine is only defined over here. And sine, inverse sine, is only defined in regions 1 and 4. It's the only places it's defined. Okay. Now, what does that mean about our friend tangent? Okay. So tangent of x. Well, let's think of just regular tangent first. Okay, so tangent theta, not the inverse, is sine theta cosine theta. Okay. Now, that's the deal. So, where would this thing be valid if we go backwards? And tangent is going to follow sine. Okay. So it's going to be only valid in regions 1 and 4. So if you ask a calculator or maybe a computer asks you, where is the angle, for instance, inverse tangent of 1, where is that? Okay, so inverse tangent of 1, it's only going to answer for things inside region 1. It's not going to go to region 3. Okay, because we made the decision, I guess, as human beings, that it's in 1 and 4. Okay, so I think that this would be pi over 4, even though there's a spot where it also equals 1 over here. Okay, but it's not going to tell you that, right? So that I think is really confusing, and I don't know how well the videos talk about it. I don't know how well, I mean, the book probably does a good job, but it's fewer and fewer people that actually read the book. So um, I thought maybe I would just mention it myself. It's something that I have to hit pretty hard when I teach the class in person. So you're online, you're doing your own thing, but maybe I'll mention it to you. Okay, and then I want to talk about one more thing, if you'll give me time. What is going on with sine theta equals 1/2? Okay, where you solve for theta. Okay, theta is the angle in which it occurs. Here, there isn't a restriction. Okay, you can manipulate things and do it with the inverse as we did before. You can still do that. You can say sine inverse sine theta equals sine inverse of 1/2, and you'll get part of the picture, right? You will get part of the answer there. But there's actually an infinite amount of answers in which that occurs, okay? The thing I just wanted to mention in this video is why that's true, okay? So this will get you part of the answer. It'll get you started. You can do this. You can plug this in the calculator. It will give you an answer, okay? You might also know the answer from just the unit circle. Maybe you know that there's an answer over here. Maybe you know that. Fair enough. But why is one restricted and the other is not? So for instance, this inverse sine of 1/2 will only give you one value. I'm pretty sure it only gives you one value. Yeah, it has to. It only gives you one value. But the sine theta of 1/2, which is the same question, would give you an infinite amount of answers. Okay, why is that? Because the inverse sine function is restricted by its domain, and this equation is not restricted at all. And that is it's so simple, it's complicated, okay? They're almost asking the same questions. I took many physics class in college, and my teachers would use this interchangeably in a physics class, and that's fine in a physics class. But in a math class, I just wanted to show why you might have that, okay? So, um, physicists know this and they just kind of use it to get their answer, and that's fine. That's totally fine. Engineers, great. But since we're in a math class, just wanted to mention why one might be the other. So I think pi over 6 would be a valid answer, but there's other places in which that occurs. It also occurs over here, okay? And then you could go around the circle an infinite amount of times and get that. Okay. So the only thing I wanted to say is why that is. I think it's really confusing and I don't know how well the materials actually explain that. So I took it upon myself to do that. I hope that this was helpful. I've already got complaints that I bug you guys too much, so I'm sorry. So I tried to keep it short. If you have any questions, reach out and let me know.